So let's talk about AI, machine learning, and generative AI. Yeah, so I mean, hopefully it's pretty obvious and clear, but AI, machine learning, and generative AI are not exactly the same things. This pillar here shows, it characterizes artificial intelligence in general. AIOps means artificial intelligence for IT ops, as we defined before. AI is software that thinks like a human through analysis and reasoning to perform complex tasks. I think the word thinks may be a little stretching the reality, but it definitely is able to process a lot of data and provide analytics similar to some human thought processes. AI is a possible misnomer, and at least even in today's technical capabilities, because it's not true intelligence as we know. But there's some goals to accomplish that ultimately in the future with generalized AI. Okay, so what about machine learning? Machine learning is a subset of AI that uses algorithms to recognize patterns from large amounts of data. Machine learning is one of several other methods for using human-like thinking for software. Most AIOps systems today use machine learning. So finally, generative AI is AI in the context that it can create new content, so text, images, code, and so on from learned patterns that it's trained on. Things like chat bots, code generation, synthetic data, and other use cases are supported by generative AI, and it augments human creativity and decision making. Definitely, it's important for modern AI ops. So let's talk about artificial intelligence in general. First of all, what is it? So AI is a broad concept that encapsulates various technologies and techniques. At the highest level, AI can be described as the replication or simulation of human intelligence by computer systems, just as a definition. There are three major categories, at least described on this chart. So narrow AI at the bottom of the image here. It's also known as weak AI. So it's very task specific, such as facial recognition with very limited parameters. It's more about pattern recognition, and not general AI, which is more of a strong AI, can solve unplanned and complex problems. So it's somewhat equivalent to human intelligence, at least in some aspects. And then super AI is AI that encompasses and surpasses human abilities and performance. To date, all applications of AI have been achieved by humans are pretty much of the narrow type. As of now, AI can only successfully complete tasks with the limited domain for which they were intended and trained on. But at some point, super AI and even more generalized AI would be able to perform activities that require human-like intelligence, and in the case of super AI, perform them beyond the capacity of human abilities. And one can argue that even generative AI accomplishes this to some extent in terms of speed and breadth of analysis of data. So what is machine learning? Machine learning is the subset of artificial intelligence that uses massive amounts of data, of historical data in particular, to generate accurate inferences and predictions. ML can be described as a subfield of AI that enables machines to learn without being explicitly programmed, recognizes patterns in the data, for example. So machine learning can imitate learning from data and gradually improve their accuracy through iterative training and optimization processes. So again, AI ops, just like AI, there are differences in AI ops and ML ops are not the same thing. It's important to understand the differences between ML ops and AI ops. So AI ops applies AI for IT operations. It uses machine learning to make operating systems more efficient and reliable and less human effort. Whereas MLOps, and this is on the quiz, so you want to remember, applies patterns brought up by DevOps towards operational AI models, implementing CI/CD testing and accelerated development cycles to the AI development model. So it's actually performing essentially, continuous delivery on the AI models themselves for development and maintenance purposes. And then MLOps can also be confused with model ops. So artificial intelligence model ops is a set of capabilities that primarily focus on governance and the full lifecycle management of AI and decision models. So it's basically focused on the models themselves. This includes models based on machine learning, knowledge graphs, rules, optimization, natural language techniques, and agents, in contrast to MLOps, which focuses only on the operational aspects of machine learning models, and AIOps, which is AI for IT operations. Model ops focus on the operation of all AI and decision models. So how does MLOps models learn? There's a different training models. So machine learning uses data to train models, just as humans learn based on past experiences. It's based on this data that the model will be able to learn how to interpret and infer outputs depending on future inputs. There are two primary approaches for providing data for training a model. One is supervised and one is unsupervised, as we briefly touched on before in the course. There are two primary differences between these types of learning. The level of human involvement required in training the model. So the increased human involvement means more supervision, and the less human involvement, the more unsupervised it is. So the task that the machine model is looking to solve is also a difference. So let's talk about supervised versus unsupervised. Supervised learning, what it's sometimes called unlabeled learning. Supervised learning requires a higher degree of human involvement, since the model will be using sample data that has been labeled for input as well as for output. So it's already been pre-processed to some extent. Supervised learning uses labeled input and output data, using the labeled data for the mode to optimize and measure its accuracy over time. There's several types of supervised learning. So regression is one example. These algorithms are helpful when identifying relations between two or more data points. For example, in forecasting, regression models are helpful in AIOps capabilities such as root cause analysis. The other type is classification. So algorithms of this type are helpful to categorize data in AIOps solutions. Classification algorithms are effective, for example, towards reducing alert noise. And the last listed here is neural networks, inspired by the way neurons interact with the brain. Neural networks are used for deep learning that can classify and model complex relationships that are non-linear. Okay, what about unsupervised learning? Unsupervised learning, as the name implies, works with unlabeled data and requires a lower degree of human intervention. Unsupervised learning models are given raw data as input without explicit human input. And the machine works to autonomously classify, identify patterns and structures from that raw data during analysis. Some examples of unsupervised learning currently being used are called clustering, association, and dimensionality reduction. So we'll talk about each of those. So what about clustering? Based on similarities or differences in the data, identify groups in the raw unlabeled data. In AIOps use cases, clustering can be helpful when events and alerts from various systems are to be grouped and interpreted together, for example, cross-domain situation understanding. Under association is a type of algorithm that looks to identify relationships in the data. These algorithms can be used in AIOps to assist root cause analysis. And finally, dimensionality reduction. So this is an algorithm used when the number of variables in the data set is too large, and the objective of the model is to reduce the number of inputs to a manageable size.